Hello, this is Mr. Howard. In this video we're going to look at factoring patterns, and being able to recognize these patterns will really help you speed up the process, and so I really recommend you try to memorize them, and the more that you use them, the easier it's going to be to memorize them. So this video is again focused on these special patterns, and this is for my pre-calculus students. At the beginning of the year we're doing just a factoring review, so that's where it's targeted for, but you could use this. There's some algebra 1 in here and some algebra 2 also. Alright, so let's start with the perfect square binomials up here. You'll notice that perfect square binomials means this is a perfect square. A plus b times a plus b in this case, and this one a minus b quantity squared means a minus b times a minus b. The easiest way I think to memorize this pattern is that you're always going to have this a squared, the 2ab, and the b squared. It's always going to be that way. The last sign, this one right here, is always going to be plus. And then this sign right here takes the sign of what is inside your parentheses here. So if it's a plus b quantity squared, then this will be a plus right here. If this is a minus b quantity squared, then this will be a minus, a minus sign right here. Alright, so that's one way that you might think about memorizing that. So I'm going to put a plus or minus here because that will vary. The next one, difference of two squares. I think that one's pretty straightforward. When you have two terms here that are being subtracted and they both have perfect square roots, then that is a case of difference of two squares. So that pattern is pretty simple. You're just going to write two sets of parentheses, and then you're going to put your a term, your b term twice here, and you're going to add them in one parentheses and subtract them in another. Notice that this is equivalent here. If I write a minus b, a plus b, it doesn't matter. Either way is correct. Okay? The order of the signs here is not going to matter. Alright. Next, sum of two cubes and difference of two cubes. So these kind of go together. I think the easiest way to try to memorize this pattern is the first parentheses is always going to be a and b, and I think it's easier to fill in the signs later. You're always going to have your a squared, your ab, and your b squared. Notice that that's true here and here. Okay, so notice that your last sign, similar to this case up here, your last sign right here is always a plus sign. So we can always count on that. Then after that, the first sign and the second sign right here just alternate. So if this one's plus, this one has to be minus. If this one is minus, this one has to be plus. And the first sign will always match what is right here. So in this case it would be plus and then minus. Alright, and then if you had this case, notice this sign takes the same sign as this one, and it would be minus plus, because these two signs, this sign right here and this sign right there, will always alternate. Okay, in both cases notice that they alternate. Minus plus here, plus minus here. And this sign right here is always a positive sign. Okay, so hopefully that will help. Now this is going to be a fairly long video. I'll just tell you now because I've got 12 examples that we're going to work through. So if you want to just skip through some of the examples, I'm going to scroll down here so you can see all of them, and that way if there's a particular type that you want to look at, I've got 8 where we're going to factor, and we're going to be applying all of these rules up here. And then I've got 4 examples where we're going to find the product, which means multiply. Okay, so you may want to skip to a specific spot that you're having trouble with, but we are going to apply all of these special cases. Alright, so the first one here, we want to take take a look at it, you notice that we have a squared term and that we have a minus sign here. So that is looking already like what? Well, the difference of two squares, right? And the next thing that we notice is that both terms, 9x squared and the 25, both have perfect square roots. The square root of 9 is 3, the square root of x squared is x, the square root of 25 is 5. So all we're going to do is write two sets of parentheses. We're going to put the square root of this one twice, once here, 3x, and once here, 3x again. We're going to put the square root of this one here and here. And then I'm going to change the color because it's kind of getting squished together there. We're going to add them in one parentheses and subtract them in the other. Okay? That's all there is to it. Okay, so that's a little hard to see, but it's 3x plus 5, 3x minus 5. Okay? Alright, let's look at this next one. So we notice we have a squared term here, we have subtraction, and both of the terms have perfect square roots. Notice that we're looking for these patterns, we're going to use that a lot, where we find, we check the terms to see if they have perfect square roots. So this is the same. It's got a different variable, but it's this part is the same as this one. So let's put our parentheses down. I'm going to give it a little more room this time. Alright, and then this one also has a perfect square root. The square root of 1 is 1, because 1 times 1 is still 1. So square root of 9 is 3. Square root of v is v. Square root of v squared is v. So we're going to write 3v both places. Square root of 1 is 1. Write that both places. And then put our signs in. So add them in one, subtract them in the other. Notice 3v minus 1, 3v plus 1. If I had the signs different, that means the same thing. Either way works. Okay, either way is correct. Alright, so let's move on to the next example. Okay, so this one we have three terms here, so we automatically know it's not going to be the difference of two squares. We have a squared term here, so we know it's not going to be the sum of two cubes or the difference of two cubes. So that just leaves our perfect square binomial rules, and remember those were the top ones up here. Alright, so the next thing that we can do is look to see if the first term, the squared term, has a perfect square root, and if the last term, the constant term, has a perfect square root. If that happens, then we've got a shot that we can apply that rule, and it looks like we can do that here. So remember that this is minus plus. We have a minus plus pattern here in our trinomial, which, if you recall from our rules, let's scroll back up real quick, means we have minus plus, so that means our parentheses will be minus. Okay. By the way, I have this this factoring patterns sheet that I made on my school webpage, so downloading that would be a good idea. Makes it a lot easier, especially when you're working through these problems. Alright, so we want two sets of parentheses, one set of parentheses, and it's going to be a quantity squared here. So we want to look at this and find the square root of 4x squared, and that would just be 2x, because the square root of 4 is 2, the square root of x squared is x. Square root of this one is, the last term here, square root of 9 is 3, so 3, and we know that it gets a minus sign. Alright, the other thing that we just need to double check here is make sure that this term is actually 2 times a times b. Alright, we need to make sure that that's true. Remember that this is taking the place of a in our pattern, and this one's taking the place of b in our pattern, and then it's quantity squared. So this term right here has to be 2 times a times b. And one way you can do it is just identify your a's and b's here. So my a is equal to 2x from the pattern. I'm using this pattern up here. Don't get confused. I'm using this pattern right up here. Okay, the a is equal to 2x. The b is equal to 3 in this case. So 2 times a times b would be 2 times 2x times 3. So that would be 2 times 2 is 4, times 3 is 12, so that would be 12x. And that matches this right here. So we're good. We know we did it right. Alright, next one. We have 3 terms. We know we're not difference of 2 squares. We have a squared term. We don't have a cube term anywhere, so we know we're not difference using the difference of 2 cubes or the sum of 2 cubes. So hopefully it's our other pattern, which would be the perfect square binomials. So next step, we look and we see that this first term has a perfect square root because 9 has a perfect square root and a squared has a perfect square root. Look at the last term, make sure it has a perfect square root. It does. Square root of 16 is 4. So we should be able to hopefully apply our pattern here. So I'm going to go ahead and label this. A is equal to the square root of this right here is 3a. Our b value in our pattern is going to be the square root of this one, which is 4. And because we have plus plus here, we're just going to add those in our parentheses. So 3a plus 4. Alright, and then the next thing that we just have to check is that, remember, 2 times a times b, right? So that would be 2 times our a is 3a, times our b is 4. So that would be 2 times 3 is 6, times 4 is 24, and then we put the a on the end, so it's 24a, and that matches this right here. So we are good. 3a plus 4 quantity squared is the answer. Alright, next example, number 5 here. We've got x cubed plus 125. Alright, already we have a cube term, so we're immediately going to start thinking sum of 2 cubes or difference of 2 cubes. And guess what? It is the sum of 2 things, so it must be, if we have a pattern here, it's got to be the sum of 2 cubes. And sure enough, the cubed root of x cubed is just x, right? Because x times x times x equals x cubed. So therefore the cubed root of x cubed is equal to x. Okay? So cubed root of x cubed is just x, and the cubed root of 125 is 5. Alright, hang on, phone's ringing here. Alright, sorry about that. Okay, so the cubed root of 125, well, that's going to be 5. You could put it in your calculator if you weren't sure, but that's going to be 5. Okay, because 5 times 5 is 25, times 5 again, 25 times 5 is 125. Okay, so the cubed root of 125 is 5. Alright, so we need to set up our 2 sets of parentheses. We're going to have a binomial in the first parentheses, and we're going to have a trinomial in the second. So to make this easier, let's just go ahead over here on the side. Got a different color so we can see it. Let's identify our A and our B in this case. Okay, so using the sum of 2 cubes, our A is going to be equal to the cubed root of this. So we already determined that was x. So our A in our pattern is equal to x, and our B in our pattern is equal to 5. Okay, so that means we're going to have x plus 5 here, x plus 5. We know that this last term, remember from our pattern up here on sum of 2 cubes, is going to be a plus b squared. We've identified that our b was equal to 5, so it's going to be a plus b squared. What is 5 squared? It's 25, so we've got a plus 25 here. Alright, and then from our pattern, let's look at it again right here. We need a squared here, so our a is equal to x, so it's going to be x squared. And then we need a plus, a minus ab here, so that's just a minus. We could put x times 5, but that doesn't make any sense. Let's put 5x here, okay? Alright, so there's our sum of two cubes. X plus 5 times x squared minus 5x plus 25. Alright, now just realize all I'm doing is applying these patterns. There's nothing more to it than that. Alright, we've got, we're adding here, and we've got a cubed term here. So we're thinking difference of two cubes, right? Pardon me, sum of two cubes. So I'm going to scroll this down so we see that pattern. There's our pattern again right there. So we're going to use it. I'm going to write that right here. So I'm hoping I'm not confusing you moving back and forth. So let's just write it. A cubed plus b cubed is equal to the quantity a plus b times the quantity a squared minus ab plus b squared. Alright, so that's what we're using on number 6 right here. Alright, so let's identify our a and our b. So in this case, our a is equal to the square root, the cubed root of the first term, the cubed root of 256. And you know what? We need to, I noticed something here. Look, we have the possibility of taking out a greatest common factor, and we need to do that here. That's always the first thing that we need to look for. Okay, 256 is divisible by 4, and 4 is also divisible by 4. So we're going to do that right now. So let's take out a 4. And then that'll make this a little bit easier to work with. So let's see, 256 divided by 4. What is that going to be? All right, that 256 divided by 4 is 64. So we're going to rewrite this, factor out a 4, and that gives us 64 plus u cubed. Okay, so we still have the sum of two cubes here, because 64, what is the cubed root of 64? Well, that's going to be 4, right? Because 4 times 4 times 4 is equal to 64. 4 times 4 is 16, and 16 times 4 is 64. Okay, so our a value here is going to be equal to the cubed root of 64, which we determined is 4. And our b value is going to be equal to the cubed root of this term right here, u cubed. Cubed root of u cubed is just u, because u times u times u equals u cubed. Alright, now we just apply this pattern right here, this thing right here. Alright, so do that in another color. Alright, so we have a plus b, so that's just 4 plus u. Okay, and we cannot forget to put this 4 out in front. So I'm going to do that right now so we don't forget it. And then we have a trinomial in the second. And it's always going to be, since this is we're the sum of two cubes, we alternate these two signs right here. So it's going to be plus, minus, and then this sign is always a plus. So it's plus b squared at the end. So that would be our b is equal to u. So it's u squared minus AB, so that's just 4u, and then it is a squared right here, so 4 squared is just 16. So all together, let's box that in. It's 4 times the quantity 4 plus u times the quantity 16 minus 4u plus u squared. Okay, so that one was a little more difficult, because we had to recognize that greatest common factor in the beginning. Alright. Okay, looking at number 7 next. So we've done two sum of cubes back to back here. And we have a cube term here, and we're taking the difference, so we're thinking already, since we're looking at patterns, that it's the difference of two cubes. So let's just write that off to the side here. The difference of two cubes, remember that that is going to be a minus b, because remember this first sign shares this sign, and then it's always a squared, and these signs alternate, so it's a minus here, so the next one's got to be plus, and then it's ab, need to erase that. It's AB, and then this sign is always positive, so it's going to be plus B squared. Plus B squared. Right there. Okay, so there is our pattern. First thing we look for is GCF. Okay, I got ahead of myself on this one, so that reminds me. Look for GCF. All right, 3 here and 648. So just get our calculator. Let's divide 648 divided by 3 there, and that's 216. 216. I'm not going to try to do that in my head, but it's worth checking before we start, and it just so happens that that works out. So we're going to factor out a 3. That leaves us with u cubed, and then we already decided that 648 divided by 3 was 216. So we have 3 times the quantity u cubed minus 216. Okay, so this term has a perfect square root. Perfect cubed root. Let's see if 216 has a perfect cubed root. Let's see, what would that be? Let's try 6 times 6 times 6 is 216. There we go. So the cubed root of 216 is 6. So let's label our A and our B from our pattern over here. So I'll do that in this same color here. So our A is equal to the cubed root of this term, so that's u. Our B in the pattern is equal to the cubed root of this term, which we determined was 6. Okay, so now all we have to do is fill in the pattern. So it's going to be u minus 6, and we cannot forget the 3 out in front, so let's put that in right now. And then we put our trinomial in. Remember, these signs alternate, so it's going to be a squared, which in our case is u squared. And then we had a minus here, so we've got a plus here. And then it's just AB, so in our case we'll put 6u. And then this term is always positive, and that is b squared, so 6 squared is 36. Okay? So we have 3 times the quantity u minus 6 times the quantity u squared plus 6u plus 36. That is the difference of 2 cubes here. All right. Next, the last factoring one of the video here, and then we'll move on to multiplying. So we have a cubed term right here, and we certainly 2x cubed does not have a perfect cubed root altogether, but notice we do have a GCF, a greatest common factor, and that is 2 in this case, because we can factor out a 2 there and a 2 there. So let's do that. Factor out a 2, and that leaves us 8 minus x cubed. And now we have a good old-fashioned difference of 2 cubed. Difference of 2 cubes. So we have, in this case, we're using this pattern right here. That again, it's difference of 2 cubes. So our a value in our pattern is equal to this cubed root, the cubed root of 8, which is 2, because 2 times 2 times 2 is 8. And our b value is the cubed root of this one, which is just x. The cubed root of x cubed is x. So now we just fill in our pattern. Okay, so it's a minus b, so in our case it'll be 2 minus x. Parentheses here. Remember, if it's minus here, this first sign is minus. This sign is going to alternate from this one. So it's going to be plus here, and then this sign over here in our pattern is always plus. So it's going to be b squared over here. That's x squared. It's going to be ab here, so that's 2x. And it's going to be a squared here, 2 squared, so that's 4. And then we cannot forget this 2 out in front. So it's 2 times the quantity, 2 minus x times 4 plus 2x plus x squared, and we are done. Alright, now let's move on to products. We're already at 25 minutes on this video. Okay, so the next thing we're going to do here is do the opposite of what we were just doing through all of this good stuff. Alright, so we want to look for the patterns here. We can already see that we have 8m plus 8, 8m minus 8. So that is looking like a plus b, a minus b, right? A plus b, a minus b. These two terms are the same, and these two terms are the same. So we've got the possibility of a plus b, a minus b, and that's exactly the pattern. So let's label a equals 8m and b equals 8. And our a plus b, a minus b pattern will turn into the difference of two squares. So it's just going to be 8m squared, 8, let me write it this way, 8m quantity squared minus 8 squared here. Okay, because it's a squared minus b squared. This turns into a squared minus b squared when you multiply it out. So 8m quantity squared becomes 8 squared is 64, m squared is just m squared, minus 8 squared. Let me fix that. 8 squared, we know what that is. That's 64. So 64m squared minus 64. Okay? So there's our answer there. So we just did the opposite. Before we would see this as the difference of two squares and then factor it. Well, now we're doing the opposite. We're going backwards. Okay. Next, we have a pattern here of a minus b quantity squared. So let's go up. We can see that. We've got a minus b quantity squared. So that's this one right here. A minus b quantity squared. Okay. So let's identify our a and our b. That always makes it easier. So our a in this case is equal to 7n and our b is equal to 2. So with that pattern, it's always going to be a squared. So in our case, 7n squared, which is 49n squared. And then it's going to be minus 2 times this, so 2 times a times b, so 2 times 7 is 14 times 2 again is 28, and then put the n on the end, so minus 28n. And then our pattern always has a plus right here, and that's b squared, and in our case b is equal to 2, so that would be plus 4. So 49n squared minus 28n plus 4. Alright, two more and we're done. Almost there. Okay, in this case we have the pattern of a minus b quantity squared, and remember that that was equal to our a minus b quantity squared was exactly what we just did, which is a squared minus 2ab plus b squared. Okay, remember that the last term was always positive, and then this term shares this sign. Okay, so let's identify our a and our b. So a equals 5x and b equals 7. So now we just fill in our pattern. So it's a squared, so 5x times 5x is 25x squared minus 2 times this, 2 times a times b. So it's 2 times 5 is 10, times 7 is 70, and stick the x on the back, minus 70x, and then it's plus b squared, so plus this squared plus 7 squared, so that's plus 49. Okay, 25x squared minus 70x plus 49. Alright, last one. We have 3r minus 4 quantity squared. So we have the same pattern over here. So let's do this one quickly and get this done. So we have a equals 3r, b equals 4. So it's going to be a squared, so 3r times 3r, that's 9r squared, minus 2 times this, so 2 times 3r times 4, so that would be 2 times 3 is 6, times 4 is 24, so it's minus 24, stick the r on the back, and then it is a plus right here always, and it's b squared, so that would be 4 squared in this case, which is 16. So we have 9r squared minus 24r plus 16, and we are done. Almost 30 minutes. That's my longest video ever. That is a record. Alright, see you in the next video.